on your worksheet, let's write what a derivative is, and this should spark a bell. The derivative of a function with respect to the variable x is, all this. The derivative, just copy that box down on page 99 in your book, of the function f with respect to the variable x. Is the function, we call this f prime, whose value at x is this is interesting. Does it ring a bell? Why does it ring a bell? When we used this earlier on, tangent line of what? Tangent line of a function at a specific point called, what are we finding? Derivative, an I word. Instantaneous rate of change. Instantaneous rate of change. So the derivative at a specific x value is just telling you the slope at that instant, right? Slope at that instant. So, provided it exists. Provided it exists. This came from your book, page 99. Okay? So we already know how to do this, right, with instantaneous rate of change. And we're going to go through using our definition here of a derivative on a bunch of different polynomials and see if we can, because the process is very long and tedious, right? If you make one side mistake, then everything's going to be wrong. So we're going to go through this process a few times until you can discover yourself a shortcut for how we do derivatives of polynomials. So using the definition of derivative, we're going to find f prime of x. F prime means it's the first derivative of the function. F of x is the function, and we say f prime, that means it's the first derivative. So on the constant, f of x equals c. Okay, we don't have a specific x value, so we can't plug in an x value, but let's plug in oops, not x approaches, h approaches 0. Let's find limit as h approaches 0. Oh, there. And we did this in class. This is your only homework today, in addition to studying for your test. Okay, f of x plus h. If we're using a constant, that's just a number, right? So is there anything to plug into? No. So c remains c. So we have to plug into. Minus, after that, so there's the original function. What is the original function? C. All over h. So if we're doing things right, everything without an h should cancel. C minus c cancel. So I have the limit. I have the limit. So you write the limit. And h approaching 0 is 0 over h. Well, what is 0 over h? 0. So we're finding the limit of h approaching 0 of 0, which is 0. Okay? And then go through this process a couple times until we see the connection of what we started with and what we ended with. Okay, our next one is the identity or linear function x to the first power. Okay, let's apply the derivative definition. Find the slope at any instant, like instantaneous rate of change is what we're doing. At any instant of h approaching to 0, then we're h of that gap. We have a secant line, and that gap we're trying to get to 0. So that we're finding at an instant rather than over an interval of time. Okay, that was x plus h. What do I write? Just x plus h. And then replace the x with x plus h minus the original function. What was the original? Just x all over h. The x's cancel. So we have the limit of h approaching 0 of h over h. What is h over h?
0.
What? 1. But we don't put in 0 yet because we have an indeterminate form. 1. So we still have not plugged in yet, so I'm going to keep the limit as h approaches 0 of 1 is just 1. Okay? Let's do it again. Now we have a square on the quadratic. The limit as h approaching 0. Okay, Nemo, can you tell me what goes in our numerator? Squared first, you have to do that f of x plus h. Okay, so what am I going to plug in for the x? It's going to be in parentheses x plus h all squared, because it was x squared, and then replace the x with x plus h. Minus, what comes next? The original, good, x squared. All over h. Okay, so I have a limit as h approaches 0. I have a perfect square here, so we can see how it's solved. How's that go? X squared, x squared. And the last one, too. In between parentheses of left is x times h times 2 plus x h times 2. So 2 x h will make that one next. I hope you guys like music because that's what I do. Okay, but don't forget there's a minus x squared afterwards. Because everything without an h cancel. Yes, if it doesn't, you've done something wrong. You should hopefully by this point have that trigger. If I don't have everything canceled out without an h, something I've done is wrong. Factor out the h. Okay? Then what remains in the numerator when we factor out the h? Oh, we have 2 minutes for that. Brendan, sorry. Brendan. But we removed an h, so just 2x plus h. And now our h is canceled. We can plug in our 0 now, right? So what is our limit, or also our f prime? It's not 0. It's 2x plus 0, which is 2x. Okay? Each time you will only replace the h with 0. Don't replace the x. Alright, let's do one more, and then we might be able to see the shortcut. Okay, the limit, as we're doing cubic now, as h approaches 0. Aline. Okay, right? Aline. What's your name come from? Brazil. Do you have Brazil? Your parents are from Brazil? Do you have more than Brazil? That's awesome. I have one of my good friends from Brazil. He's from Sao Paulo. Cool. Okay, Aline. What is the numerator going to execute the function that we have to do after x plus h first? Good. Minus what would be the last part? X cubed. Okay, all over h. That's how we change now, no. That's your credit.
Additionally, today, 250 cafeteria will be a mentor-mentee meeting, an opportunity for you to come and meet your mentor if you're a teacher or software company.
squared over h. You can do the column for the squared part, and then multiply to the third binomial. We're going to save the x plus h for a time being, and just do the square. How's this one go? First square the first term, square the last one too. In between the first and last is first and last times 2x minus 3. You see how each time our power increases, the problem's getting more and more complicated, right? Especially if it's getting more and more complicated. So hopefully, you're not going to make us do this recipe. Hopefully, we can find the pattern by in the cube, because multiplication is going to be even more work. So we have to start multiplying in the h and the h. Limit as h approaches 0. Times this binomial. Oh, that was not what I wanted. Timesing the binomial to the trinomial. Okay, I want you to try to finish that very carefully. Very carefully multiply those together and see what the limit is. I already know what it is. So, because once you know how to do derivatives with shortcut, you can do this one in your head. Yeah, algebra, that's the hard part. You guys have it? What you just showed? There we go. Think you ever know what that is? In the back. I'll tell them that jump to, yeah.
I'm only going to be like 7 days like walk on it. And from there, it's like
There's some good guys. I'm sure you'll still feel it. I came out for 10 months in my list in January, and it wasn't until this month that I could actually move my list around. So, yes, but you didn't move the wrong way. You moved the shortcut way. Well, see, everything cancels. It doesn't have an H. Yes. Good job. Okay, I'll do it and see if you might be right what we missed here. Okay, that's the big long thing. Everything without an H should cancel. X cubed, negative X cubed. Everything else has an H, correct? An H. So, limit as H approaches 0, just factor out H. I think I have some like terms. X squared H's. That's my terms, X squared H's. How many small X squared H's are there? 3. So I factor out H to get 3x squared. That's what I terms, X H squared. X H squared. They're also 3. So I factor out an H. I'm left with plus 3xh. And then that guy doesn't have my term. So I have an h inside of plus h squared. Alright, the h cancels. Let's plug in 0. What's the happen with this middle term? Cancels. What happens to h squared? We put in 0. Cancels. So our answer is 3x squared. Solved. Some of you might have already figured out the shortcut. This is called the power rules, which are polynomials. You got it out of here? This way? This way? It was not at me. It should be this way. Originally, we had a constant, which was 0 power. 0 power. We had a constant, which derivative was 0. We had x to the first power. The derivative is 1. We have x squared, this is where you really start figuring it out. X squared, the derivative is 2x. If it happens, x squared, the derivative is 2x, return to the pattern. X cubed, the derivative is 3x squared. So you're going to notice the power rule, the pattern, what's happening each time. Pattern time. Exactly, good job. The power rule. If we have f of x equals x to the n, our derivative f prime of x will equal, we bring the power in front, multiply it, kind of like logs and bring that in front, x to the n minus 1. You decrease the exponent. Next, we're going to watch a short video introducing the inventor of Calc, the inventor's flow of calculus, and we'll continue with this as well next time you need after the test. So next time is the test. Your only homework is the purple worksheet. If you have this, the back side, to finish the back side and study for your test. Okay? Any questions? Okay. Good job because of the power rule. There's so much energy. When you're awake, get up energy, right?